Or you just I will go to one by one slide only, just by one click, 1 second click. So NIC, MAC addresses, or to check MAC address, cables, coaxial cables, twisted pair cable, UTP, STP cables, then okay, and then fiber optical cables, devices, hubs, repeaters, switches, router, modem, okay, and how it is there, and topologies, bus topology, ring topology, mesh topology, and star topology, tree topology. These are the networking commands. We'll also see some commands. Okay. And yeah, I've done a little reverse kind of stuff. So that's why it is OSA layers. Okay, 7 layer model, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And there is a protocols and port numbers. Each protocol represent what kind of service or what kind of request kind of stuff. Okay, what is the service? What is the request? What is the server? Three things are involving. Guys, this is more important to understand lot of things. Okay. HTTP, HTTPS, FTP, SSH, Telnet, RDPS, MTP, POP3, IMAP, TFTP, DHCP, DNS, NTP, Kerberos, LDAP, SNMP. Different protocols having port numbers. Next one is what is the difference between TCP and UDP? So one is acknowledgement based, another one is not an acknowledgement based. Of course, elaborated answer you had to tell. Okay. So this part, ping reply wise, I didn't tell you how to troubleshoot ping reply wise. We'll discuss that one also. And the certain commands, networking based commands also, we'll see it. OSA TCP differences. If anybody want a revision for OSA layers, also can do a quick revision also after completion of IP addresses. So then, so next part is, of course, the last part in the networking is about a IP addresses. So here it is. What is an IP address? IP address is a logical address. The IP address network is a logical networking. Okay, physical topologies like bus topology, ring topology, mesh topology, star topologies. This is a physical topology, physical connectivity. But this is logically, we are grouping devices to communicate each other using logical addressing called IP address. IP address is a uniquely identified device in the network. It is not a unique address. It is uniquely identify a device in the network. So we can identify a network. In the network, we identifying the devices separately. Like these are 4 computers. All 4 computers physically and logically same network. And their host IDs are changing like 11, 12, 13, 14. By that one we can understand the different host IDs. 1 second. Right. Again, someone is wantedly playing, or I don't know, because it is some kind of playing only. Because yeah, last time someone gave, like if you are giving a number in a, then I have to give a complaint, or I have to do something. Like a white hat junior. I thought someone kid is tried. And my number is someone is trying to generate a OTP, and I'm getting a call. But this is a complete fraud calls. Don't understand that. Now it is some rummy type. So the not one call. So I'm getting a lot of calls. One call is that is normally we'll get one call and then stop, right? Not that many calls we will get. Yeah, sorry. I'm muted and not muted. Are you able to hear, guys?
Yes, sir.
The screen is visible, right?
Yes, sir.
Yes, sir.
So IP address can change, or we assign an IP address according to the network. Okay. So a lot of things are there. So again, that is important one is difference between IP address and MAC address. IP address is a logical address, and MAC address is a physical address. You can change an IP address according to the network, according to your requirement, right? But MAC address cannot be changed. MAC address is fixed address. MAC address is fixed address. MAC address is fixed address. MAC address is fixed address given by a manufacturer of NIC. But IP address is not given by manufacturer of your NIC. It is given by DHCP server, or manually we assign an IP address. So in IP address, there is a private and public type of IP addresses. In generally, our laptops or desktops having a private IP addresses in within the LAN communication. But when you are communicating outside, it is they use you have to use public IP addresses. That is different scenarios. I will explain that. But in this one, MAC addresses never using MAC address not valid outside of your LAN communication. Okay, outside of your LAN, so your MAC address is no one knows. Okay, so we cannot access with a system. We cannot send a packet with a MAC address. Okay, even it is a LAN communication or a WAN communication. Okay, of course, anyway, there is no private public. It is a fixed address. It is in IP addresses. We have a two versions available. One is IPv4, another is a IPv6. IPv4 is 32-bit. IPv6 is 128-bit. MAC address is 48-bit, and it is represented in 12 hexadecimal number is. Again, all communications by IP address only. We cannot address, or we cannot send a packet with the MAC address directly. While you are communicating, the packet contains, when you are sending a packet from source to destination, the packet contains source MAC address, destination MAC address, source IP address, destination IP address. But when you are communicating, your address is We communicate with the IP addresses. We can address some device with IP address, but we cannot address by like we are addressing and sending them with the MAC addresses. Of course, we use a MAC addresses in different scenarios to make it for a security purpose or anything. Okay. So sorry, because of these calls, my mind is completely disturbed. Okay, in IP addresses, again, IPv4, IPv6 differences. Okay, again, so someone is really wantedly playing or something really there is a problem. Yeah, IPv4, IPv6. IPv4 and IPv6, the 32-bit and it is a 128-bit. So 2 to the power of 32, 4.3 billion cycle. 2 to the power of 128 means 3.4 billion billions of IP addresses. The almost is 3.4 into 10 to the power of 38. The decimal format. So IPv4 is represented in decimal numbers only. In IPv6 is represented in hexadecimal format. So your IPv4 is 32-bit. Okay, to write in a decimal format in the four parts. So it is four parts are there. So each part is a 8-bit size. 8-bit size. Okay, and it is divided by dot. So totally four 8 bits. Total it is 32-bit size. Okay, each part we call it as a octet because it is 8-bit. We call them as a octet, and they are separate with a dot. The size of the each octet is 0 to 255. 0 to 255. So 2 to the power of 8 is 256 means 0 to 255. It means in this one single octet, it is the number either 0, 1, 2, 3, maximum 255, not more than 255. Okay, and whereas IPv6 hexadecimal format, hexadecimal format, you can see it's a very big lengthy. How it is? Because it's a 128 bit. One hexadecimal number is represented in a four binary digits, four binary bits. Okay, so one hexa number, for example, you take A. A is 1010 in a binary, means 4 bit. So maximum number is a 4 bit. One hexa is a maximum size is 4 bit only. Okay. Okay. So 4 bit means 128 by 4. It is 32 hexadecimals are there in a one single IPv6 address. We can write in a different ways, guys. So here it is. The 32 hexadecimal numbers are divided into 8 blocks. These 32 hexadecimals are divided into 8 blocks, divided by colon only. So they're separated by colon. Okay, 32 means each block contains 4 hexadecimals. Each block contains 4 hexadecimals. So this is my one of an IPv6 address. We can write like this also, or you can take an IP address like this. So it's a purely depends upon the how it is there. Okay, it's so the IPv6 it is different ways it is there, but totally if you write elaborately it is 128 bit. It means 32 hexadecimals are there. Okay, so depends upon the zeros, leading zeros, and way of writing may changes, but it is so. This is IPv4. The first part we call it as the first octet, second octet, third octet, fourth octet. W.x.y.z. W.x.y.z. Okay. The first one, some people might make it more easy. The first one is the W part, X part, Y part, Z part. Or I can say first octet, second octet, third octet, and a fourth octet. So each octet size is 0 to 255, not more than 255. Any number you have seen, it's a more than 255 in any of the octet is invalid, and total IPv4 addresses from starting with 0.0.02, the final address is 255.255.255.250. Okay, of course. Here it is. One more point about IPv4. The loopback or local host is every PC itself. Call it as a every PC has their own name. Every PC has their own name and their own IP address. But every PC has a common name called a local host, and that local host IP address is 127.0.0.1. Okay, so it is a self kind of stuff. It means you are accessing to your own PC, you are pinging to your own PC. So then it is the name is a local host and IP address is 127.0.0.1. But when you are communicating to the another PC, then compulsory you can see here it is. I try to access from here to this EPC. So I'm trying to access from A to EPC. Then I have to use EPC IP address. Okay. I want to access some service which is inside a EPC from EPC. Then I use a local host also possible. You can use local host name or a IP address 127.0.0.1. It's a loopback address also use it for self-testing purpose. Self-testing purpose also you can use it. But when you are accessing a service or some folder or some connectivity, some sharing kind of stuff, okay, anything like you are accessing from other PCs, so definitely have to use this PC IP address. So again, what is the local host? This localhost IP is 127.0.0.1. Okay, are also called as this is a loopback address because it's a for using self-testing. This is the how to test self-test like this. Okay. Every PC name is itself a local host itself. Okay, their IP address is 127.0.0. You can ping to name called a local host or a IP address. What is the meaning of this self-test? Basically, in your system, TCP IP related services are running. When you want to communicate to any device, first of all, a TCP IP services should work, right? So if it is not working, you cannot able to communicate. So there is whether TCP IP, the drivers, TCP IP application running or not, a suit is running or not. So then we can able to understand from this ping request. Mostly it is successful. Colon one is a IPv6 address for the local host. IPv6 address for the local host. Same colon represent 0.0.0, like it is unknown IP addresses or certain sources we use. Okay. Of course, in IPv4 we have a unicast, multicast, broadcast. But in here in IPv6, unicast, multicast, anycast. Unlike IPv4, in IPv4 we divide a total IP addresses from 0.0.0.0 to 255.255.255.255. The total IP addresses we are divided into the five classes. So the class is based on the first octet range only. The class is based on the first octet range only. It means in the W position or a first octet position, or we can say W position, the IP address. Like this, it is 127. This is a W position, 0 W position. Okay, here it is 197. Here it is 151. Here it is a 120. We have to look at that one and we can understand which it is, which class it is. Again, class A is 0 to 127, and it is actually written in a certain textbooks and certain websites. It is 1 to 126. Of course, there is a reason why, because of 0 dot 0 dot.
ايش بفكر
Yeah, tell me.
نو سير ماكوش متي
0.0.0.0 is a reserved IP address, and that entire 0 series also we are not using. We are used is 0.0.0 in the DHCP um, client to server communication side. Okay, in some default routing sites we are also using. Anyway, it is become reserved. We don't use. We don't use means we don't assign to a PC or a computer or a laptop or a mobile phone. Like we don't assign to a device. This entire IP addresses we don't assign to any devices. Same goes for a 127.0.0.1. It's a reserved IP addresses. Okay, it is a reserved IP addresses. Also, it's for a local host or loopback addresses. And entire 127 series is we are not using. Okay, meaning is we don't assign this 127 with any other numbers. Also, we don't assign to any device, any NIC. We don't assign. We cannot assign. Okay, that's why it is written 0 to 1, 0 to 127, and in the brackets 1 to 126. Some people tell it is 1 to 126 only, but original range is 0 to 127, and of course the usage range is 1 to 126, because 0 is 0 series is reserved and 127 is also reserved, and 127.0.0.1 is a reserved IP address. Okay, class B 128 to 191, class C 192 to 223, class D 224 to 239, class C 240 to 255. And class C I range is a 240 to 255. This entire range we don't use it for assigning an IP address to any adapters, because it is reserved for a future use or maybe some research use or still in a research kind of stuff, or maybe somewhere using we don't. Class D is a multicast address 224 to 239. You see any IP address which is starting is 224 or 225 or 226 up to 239, it is a multicast address. Of course, these multicast addresses also we cannot assign to a any device, any single device we cannot assign. Multicast addresses are used by certain protocols for multicast the data to multiple pieces. For example, I want to install a operating system in the 10 computers. Through the network, I can install operating system. So I use a bootp protocol, boot DHCP protocols to distribute each and every device identified with an IP address separately, unicast IP address only. But all devices, these 10 devices, all these 10 devices, I am giving from my server, I am giving my operating system files. So I'm deploying my operating system to these devices. That time I use a multicast IP address. So certain protocols they use this IP addresses not to assign to the any device or any host. Okay. So class C, class B, class A or class A, class B, class C is a unicast range. So you can assign any IP addresses to any devices, of course, except 0.0.0.0 and enter 0 series, 127.0.0.1 and enter 127 series we cannot able to. Of course, there is a certain rules also there while you are assigning an IP address. That is also we'll see in at the time of network ID and broadcast ID time. That is also we'll see. Of course, anyway, we are in a unique IPv6 is also there, guys. IPv6 having a link local IP address, global unicast IP addresses, private IP addresses, multicast IP addresses, unicast IP kind of IP addresses also there. When you see an IP address FE80, it is a link local IP address. Starting FE80 with something, some number will be there. So that is a link local IP address. Observe. It is a kind of private IP address only because it works in the within the LAN only. It works in the within the LAN only. Okay. To get these IP addresses, you don't require any DHCP servers or any special servers not required. It will be generated by system itself only. Using the NIC's MAC address, this IP address will be generated. So nowadays, like just in your NIC, IPv6 should be enabled. So go to control panel or ncpa.cpl. I will go to ncpa.cpl. Okay. If you see, I have a link local IPv6. I have a link local IPv6 FE80 colon something number. How it is came based on my PC's MAC address. My system calculated and assigned an IP address like this for my NICs. It is almost stable. It is automatically generated, but it is still useful. We can able to communicate with this IP address. Able to communicate with this IP address in the LAN. Even you don't have a IPv4 address, you can use this IP address to communicate within the LAN communication. In the LAN. Okay, that's what I am trying to say. Very simple. So this is link local IP address. It is link local IP address. How it is came? Go to properties. IPv4 is there and IPv6. Check mark. The check mark. IPv6 properties. See, there is nothing showing on here. It is trying to get IP address from automatically. No assignment. No assignment. But if it is failed to get an IP address or it is successfully get an IP address, whatsoever it is, there is a link local IP address to communicate within the LAN communication. If in case I remove this check mark for IPv6, if I remove this check mark for IPv6, what will happen? We'll see. So where is this link local IP address? It will be gone. It will be gone. So now it is only IPv4 type network, not a IPv6 kind of, not even a link local IP address. It's purely depends upon so like this. Even if I check it, maximum I will get a link local IP address. Okay, I will get a link local IP address. So if you look at this, in this one, I'm getting some other IP addresses. And this is some, not even a original IP address, some local kind of stuff on it. Private IP addresses. It's a purely depends upon your router. But you want to get a IPv6 address, and even your router is, means your DHCP, you don't have a DHCP server with a IPv6 facility, still you can able to communicate within the LAN using that link local IP address. That's the point, guys. Very simple one. Okay, so here we are there, IPv4 classes yesterday. So yesterday I want to continue these parts, but no one is there. So then I have to jump from there. But we didn't wasted the time. Utilize. Guys, understand up to here all the IP addresses, ranges kind of stuff. Understand up to here what is IP address, IPv4 address, and their ranges. Guys, if you understand, you click I understand, no understand, no understand. Do not wait for others to respond. If anybody having a doubt, they will ask. Really, guys. I want to ask a question, then you are not speaking and I am stuck somewhere. My screen is stop working or mic is not working.
Working now.
Now you are able to hear?
Yes, sir.
Yes, sir.
Then why people are not speaking? Ask simple, do you understand or not? Okay.
Yes, sir.
So which class it is? We have to look at this part only, not at these parts. We have to look at the first part only. Which class it is? 120. See it is. Where is 120? In between this. Then which class it is? It is a this
Latif.
IP address is belongs to class A. Very good. Now tell me this one. 151.
Sir, it is also class A.
151.
Class B, sir.
Class B.
128 to
Class B.
190.
This is 197.
Class C, 192 to 223.
Very good. 224.
4.
Of course, direct only it is. Which class?
Class D.
240. Then now what is this? 170. 192. 240. So 170. Which class it is?
Sir, class B.
Class B.
Class B, sir.
Class B. Great. Okay. So this is when you see first of all, when you see an IP address, check all the octets. Any octet is more than 255, it is invalid. It is invalid. For example, I have an IP address like this. uh, 156.80 dot to 89.67. For example, simple like this. Okay. See,
It
you
is
see, this is more than
wrong.
255. It is invalid IP address. For example, um, it is like this,
It is
and
valid, sir.
valid now. Now it is valid.
Valid, sir.
Okay, this is invalid. This is become valid. Just for our understanding only. 150 valid, 250 valid, but we don't use it. But as an IP address, it is valid. 150 means it is a class B. 250, 250
Class E, sir.
is class
Class
C.
E, sir.
But still it is a kind of IP address. We cannot use it, but still it is an IP address. Okay, guys. So compulsory identify basic only. It is a very basic. When you see an IP address, understand which class it is. Okay, that's just very good. Here it is. First starting only. I've written something like a 401, 402 kind of stuff. In the same scenario, it is comes here, guys. Your IP addresses are divided for different type of purposes are there. IP addresses starting is 0 dot 0 dot 0 dot 0 and 1 2 it continues. The final number is I am not writing every number, so directly I'm writing final number 255 255 255. Okay, so this is totally 4.3 billion IP addresses and it is divided into 5 classes. Okay. So of course, different purposes are there. One is, guys, if you want to give an IP address for each and every device, then what happen? I can give the device IP addresses to only 4.3 billion only. You know, billion means 100 crores. Our Indian population is itself like a we have a currently 4.1.4 billion. Okay, 1.4 billion, and each person having a devices now even means 100% we may not having a computers kind of stuff, mobile phones kind of stuff, but still we have a populated more devices. Big countries like America, Australia kind of China kind of countries, India kind of countries. It also is a big country, more populated and more devices, more development. So even for 1 or 2 countries, it is not enough. Then how it is? Globally, we can cover with the IPv4. Of course, that is also big challenging today. That's why we are choose IPv6 now. But whatever it is, now it is IPv6, but before it is IPv4 only, right? So there is a little challenges. So for that's why we divide a IPv4 the total range from 0.0.0.0 to 255, 255, 255 into 5 classes. And after that one, first 4 classes are useful classes. First 3 are unicast, and the fourth one uh, class A, class B, class C are a unicast. Class D is a multicast, and class E is a R&D type. Okay. So what's our it is, guys? So another reason I'm trying to say is understand this network and host kind of concept. Okay. Here it is. I'm in a fourth floor, so then my room number is, for example, 402. Okay, which is 4 represent floor, 2 represent door number, for example, 405, 406, 410. What all these 4 represent, all these things are represent the first number representing floor. Okay, and next 2 digits, these 2 digits representing door or flat, right? So like even our pin numbers, for example, my area pin number is like a 5300 72 something is there. And in Hyderabad, we have a different number 00016 is there. The 5 represent as a British wise coding. The 5 represent a state or a postal area of a state, mainly Andhra Pradesh, Telangana, and some parts in Karnataka, some parts in Tamil Nadu. Again, 0 means it's a main city. That city start with the 00. Third represent different city representation. This is area representation. Okay, this is a particular sub area representation. Even you can see like a 4000 Mumbai, Maharashtra, 411058, the Pune. Okay, like a 11, which area it is? Again, Delhi kind of stuff. 60, Chennai related. So point is, we are logically dividing these numbers for easy to identify the devices. See the identification, and this is group like this one network kind of stuff. So your network is your IP address is two parts. One is network ID, another one is at host ID. No problem. Now only we are started. I told a big story now. All revision I have taken. All IP address revision. Okay. So here it is. We have a class A, class B, class C. These 4 octets. Okay. In each classes, the octet representing the network and host portion. So guys, remember a rule here. Always network must be same. For example, network is 1, host is 1. Network is 1, host is 2. A network is 1, host is 10. Network is 1, host is 23. All are same network. All devices can able to communicate. All these 4 devices can communicate each other. Understand the notation. Just for a notation example, I'm telling. Personally, it is 2 digits are not there. Okay. Always check the network portion. Both computers or both devices having same network portion, then they will communicate each other. Both are in a different, of course, host is a identity. So like as I said, a door number or a roll number. Roll number is also identity, right? So like that. This host number is identification of a device, and network number represent identification of network. So same network means network must be same. For example, 2.2, 2.3, 2.5. Okay, Again, it is separate network because network is different. Okay, network is different means this network is different. This particular network is okay. Guys, understand network and a host part. Okay. So here it is again. There's some rules are there. Device must be in the same network to communicate each other. Device network portion must be same. Network ID must be same. Okay. If you want to make communication between two or more different networks, the network is different to each other and you have to use a router here. So why it is a router? It is an inter-networking device. Router makes communication between two or more different networks. Okay. But point is very simple, guys. You have a computers, 10 computers are there. Okay, like this, you have a computers. Someone's IP is different and means their network is different. You have to correct it, that's it. In the LAN, and you have a 10 computers in your LAN network, their network portion must be same. You have a 50 computers in your LAN communication, you are saying this all 50 computers are same network. Means their network ID must be same, that's it. Okay. For example, you have a room with a 50 computers here as a single logical network. Okay. And you have a somewhere like a in another some 50 computers are there. They're all in the same network, but both are in a different networks. And you want to maintain both are both these 50-50 separate as a networks. You want to maintain this is separate network, this is separate network logically. And you want to make a communication between these networks, then you can use a router. Okay. So I think you don't understand, no problem. See. Right. You have a computers in a network, in a one single network, you have a computers and you assign an IP address to each and every device. Somewhere there is a problem like one device IP address is entered wrongly and it is a different IP address, means different network. Then what to do? To make it communicate, you have to correct the IP address. That's it. So for that purpose, again, you don't use router or a switch or something, we don't use it there. Okay. So you're writing a sequence letter. Suddenly I write a 503 here. Okay. Instead of 403, I've written 503, for example. What to do? You have to correct it. Make it as a 403, right? So same thing I'm trying to say. Whatever it is, guys, point is enter your IP address, the four parts. Okay? Your IP address based on the classes. It is divided into your IP address is divided into network portion and host portion. First example I'm taking class C type of IP address. Class C. In a class C, network, and host portion. Means first three portions are network portions. The last portion is host portion. For example, you take a class C IP address 192.168.10.115. So these three are network portions and this is the host portion. For example, I have a computer called a PC1. So IP address is I assign like this. In the same network, I have another computer called PC2. Then I'm assigning like this. But don't confuse, it is allowed. In first octet, it is not allowed. This is okay. This is the correct one only. Now, see it is when you are saying is these two computers will communicate each other or not. PC1 to PC2 will communicate each other or not. See the first octet is same or not? Second octet is same. Then third octet is also same. Of course, this is the host portion. No problem. They will communicate each other. Guys, understand? Two systems will communicate each other.
Yes, sir.
Okay. See again. The host portion can be different, no problem. But here it is, see, I have another computer, I configured IP address like this. 193, 168 and 10. See it is, in this one, these are as same. All three are same. But in this one, the first itself different. Okay, this is different. So it won't communicate each other. This second and third is same. Even that is a same, but still it is, here it is a different. So this PC cannot communicate it to PC1 or a PC2. Similarly, you take a PC4. I put a 192, 169, 10, 104. Whatever it is, 104 it is, but you see, this is a different 169. So it is also won't communicate. Guys, so compulsory all the octets are same or not. All networking octets are same or not. Okay, so that is what we can able to say. In a class C network and host portions. Okay, again see, depends upon which class it is, the network and host portions changes. I said about a class C network and host portions. First three are a network portion, the last portion is host portions. Okay, in a class B, I am coming from reverse side. Class B, first two are a network portions and second two are a host portion. Okay. For example, I am taking an IP address. This is class B only, right? 172, so class 16, 15, 40. Okay. So which one is a network portion? Network, network. Host, host. I have another computer. I have another computer. That is, their IP address is 172, 16, 43, 114. Okay, no problem. And it is 41. But if you look at here, network portion is same, that is enough. So this PC1, for example, this name is PC2, they will communicate together. Okay, so you can see two portions are different portions, or maybe a same portion. You can also, some people say both should be different. No, no. So this is same, no problem, and this is different, also no problem. Okay, so these two portions, either this is same and this is different, no, no problem. This is different, this is same, no problem. Or both are different, no problem. But both are in the same network only. Guys, it is a only identification things. Okay, same class or different class. Of course, you have to give non-communication kind of stuff, right? So it is a 172, 17 dot, 15 dot, 42. It is almost all both are look like a same, but there is a problem. See it is this is the problem. So this IP is different. This portion is different. So this is cannot be communicated. Similarly, you have a 170, 16, 15, 123 or 151.123, whatsoever it is. In this one, this is good, but this is also won't communicate. It's the 172, it is 170. So obviously, this one is also not able to communicate. You guys understand network and host portions?
Yes, sir.
I'm going to the last one in network and host part. Okay, the first one is network portion. So remaining are a host portions for a class A. Okay, class A. The first one is network portion, remaining is host portion. For example, I have a 110.13.14.115, just for example, and 110.3 um, 52 dot 63, whatever it is, there's no difference. By passing, so look at here. Network, same. So both PCs will communicate each other. This is the, for example, PC1, PC2 will communicate. Even it is remaining is look like a different, but this is correct. Okay. Next. For example, you taken different one. So 11 dot 3 dot 3 dot 64. It is 11. It is a 110. So obviously it is won't communicate each other. Remaining three portions can be anything, no problem. Or same thing, no problem. Same kind of stuff, no problem. Or different kind of stuff, no problem. But same to same should not be there. For example, you have seen in this between, for example, this is also 13, this is also 14, 115, like this 115, same IP, right? Same IP also danger. I will show you that one. Okay, once you understand this part, it is. I have a PC1. PC1 IP address is um, 10.1.3.4. Okay, and I have a PC2. 10 means same network. 1.3.5. No problem. Because in a host, one variation is there automatically. You can understand. Host is means simply it is a sequential order. Network means it is a same group, same network or not kind of. Next 10.1.3.4. This is PC4. Now what will happen? These two pieces won't communicate each other and it is not communicate with anyone. Okay. For example, I have another PC with 1.2.4.6. These two will communicate each other. These two won't communicate each other and also cannot communicate it to anyone also. That is called a conflict. What is conflict? Conflict means two or more devices having same IP address, called a conflict. When it is a conflict, the conflicted devices won't communicate each other or any other devices won't communicate it to conflicted devices. Remember, what is conflict? Two or more devices having same IP address, both network and host, both are same. That is called a conflict. Okay. Let's understand. network and host portions. If you see Class C is having a one host portion, means one octet is completely belongs to host portion. One octet means 8. 2 to the power of 8, the 256 minus 2, 254. Okay, what is this 254? In your network, in your network, you have a computers, 10 computers, 20 computers, 50 computers, right? You have a, and I can able to give IP address to each and every device. Okay, I can give an IP address to each and every device up to 254 IP addresses I can able to distribute. Up to 254 IP addresses I can able to assign in the one single class C network. In one single class C network. Single class C network. For example, 192, 168, 1.0. It is my starting IP address. First IP. Starting IP. This is, we call it as a network ID. This is network ID because it's starting with a 0, means this part is started with 0. Host portion, single host portion is completely 0. The host portion is completely 0. Okay, it is nothing but a network ID, starting IP. So we cannot assign this IP address to anyone. Next one is 192 dot 168 dot 1 dot 1. This is the first valid IP address. First valid IP address. Meaning is you can assign an IP address to a PC or a device from this one. Then it is go to 1.2, 1.3, 1.4, and finally it reach 1.254. 192.168.1.250. Next 1.255. That is completed. 192, 168, 1.55. Guys, this last one. How it is last one? If you see, the next IP is 169.1.0. This is separate network. It is a network ID. See, network is finished at this place. This is total network IP. Of course, I'm not writing everything. So it is 1.0, 1.1, 1.2, 1.3, 1.4, and 1.5, and 1.255. It is a last IP in this. This is called a broadcast ID. Last one we call it as a broadcast ID. Use it to broadcast a message within the network. Last valid IP address. This is called a last IP, last valid IP. This is the first valid and this is last valid. Means 1 to 254 we can assign to the devices. We can assign these IP addresses to devices. We cannot assign an IP address 0. We cannot assign an IP address 255. Okay, guys, understand this range.
Yes, sir.
Okay, so this is the range. So first one is network ID, last one is broadcast ID, remaining is host IDs. Remaining we call it as a host ID, valid host ID kind of stuff. We can assign to a devices. So total number is 0 to 255 means 256 minus 2, 254 minus 2, 254. So totally 254 number of devices will get an IP address. 254 IP addresses without changing the network ID we will get in that. And coming to the class B, two host, two are a host portions. It is network, and this is a host portion. Two host portions means two octets are host portions here. Two octets are two host portions here. So 2 means 2 into 8 means each one is 8 plus 8, 16. 2 to the power of 16 minus 2, 65,536 minus 2, 65,534. So this is our class B. Okay, it means one single class B network. In one single class B network, okay, I can connect devices up to 65,000. Okay, 65,000 computers, IP addresses we are getting from one single network. For example, sorry, I have 172.16. Yes, it is one of the class B, right? 0.0. So this is network. This should not be changed. How it is happen? 0.1, 0.2, and finally, not finally it is. You have to count like a 0.255 and 1.0 in 1.1. Okay, it continues. Finally, you reach 255.254 and 255.255. This is called a broadcast ID in this network. This is called a network ID. This entirely one network. This is the first valid IP address. This is last valid IP address. This is the range of IP address. The total is 65,534 IP addresses. What about remaining two? One is network ID and the one is a broadcast ID. Once you cross it, then your next IP is look like this one. 172.17.0.0. This is the next one. After this is the next one. See, it is network ID is getting changes means it's a different network. 65,534. Same go for a class A. It is a 3 host portions means 3 8s 2 to the power of 24 minus 2, 16 million, not a billion kind of stuff, guys. 16 million 777,216 total IP addresses. After that one is a network ID, another one is a broadcast ID. If you remove that one, 16,777,214 host we can able to. Okay, I will give you a small example, like which one is class A or class B or class C kind of stuff. For example, I have a network, 50 computers are there. Now I want to assign IP addresses to each one. Only 50 computers. Which is the best? Which class is a better one? I choose class C because 254, of course, I am having 50 computers only and I am getting 254 in the one single network. Okay. Next, my boss increased my computer capacity. Now additionally 50 computers are there. It means now it is 100 computers. Same class C. Then another 100 computers are added, 200 computers. We can continue with the same class C, that IP address only, that same IP address, no problem. We cross 300, then your IP address is no longer used. Then we have to move to class B for 300 computers because class C can able to support one single network. It support only up to 254 devices or 254 IP addresses it will give one single network. But class B 65,534 IP addresses for a single network. Okay, meaning is those many devices you can able to connect it, those many IP addresses we can assign to the different devices. Okay, so you have a more than 254 means better to choose class B. You have a 5,000 devices. I need a 5,000 IP addresses. Class B. I have a 50,000 devices or 50,000 IP addresses required. Class B. Okay. If in case you cross more than 65,534 IP address requirement for your network, for a network means you have to go to class B. Again, entire IP address thing is changes to class B. Of course, you can connect up to 16 million devices. Okay. If you see the bottom, guys, there is a IP address 100.10.20.a. It is a class A IP address. The network portion is first portion 100. Remaining is host portion. Second one is 150.10.2.190. Okay, it is a class B. The first two are a network portion means 150.10 must be same for all the device IP addresses in the same network. Okay, and the next two portions are a host portion. Class C is 1201.2.100.250. It is a class C. First three portions are a network portion. So 1201.2.100 is a network part and the last part is host. Already I told guys to communicate in the network. So the both devices IP addresses must have same network ID or a same network portion. It is two PCs, PC1, PC2, 172.16 because it is a class B 172.16 is a network portion. So both are same for PC1 and PC2, then both will communicate each other. Even it is a same for PC3, so PC1, PC2, PC3 can able to communicate each other. PC4, the second portion is become 17. Obviously, PC4 cannot able to communicate to the PC1 or PC2 or PC3. Same goes here also. It is a class A type of IP address I have taken. I have a three PCs, A PC, B PC, C PCs. A 101 means class A. So that 101 is a network portion. Class B network portion is also 101. So A and B can communicate each other. To take C, the IP address is so that network portion is 100. It is different from A and B, so it won't communicate to A and B. A and B will communicate each other, but not with a C. Again, in a bottom C, there is a 5 computers, and first computer IP address is 201.110.2, 201.100.103. Means the first three portions are same. 201, 201, 100, 100, 10, 10. So obviously first three are same. Obviously it is they will communicate each other. Class C and D, sorry, so not it is a class C, PCC, PCD, PCE. If you see, there is some difference in their any of the octet, either first octet or second octet or third octet. So there is a difference between A and B. So A and B communicate each other. C, D, E cannot communicate it to A and B or with each other also. So this is about network and host portions of an IP address, guys. The next one is default gateway. So you understand what how to check the network and host portion and make sure both are having same network or not. Okay, so here it is. In again, I have written C. Both devices must have same network ID or a same network portion. So both having a same network portion or a network ID, they will communicate each other, right? That's what I'm trying to say. They will communicate each other in the same network type. Each other means same network. I'm in different network. Google.com is in different network. I am able to communicate, of course, via the routers and all. We are able to communicate. Okay, that is a different part. But here it is. I am talking in a within the same network, means same logical or physical network. Same. Okay, guys. Here it is. We understand the by looking at an IP address, which class it is, and what is their network portion and how host portions. So, but how system will understand? System use a the subnet mask. This subnet mask tells what is your network ID. So, what is the part of your network part? Okay, so that is will be tell by subnet mask. Subnet mask divide an IP address into network and a host portions. Subnet mask use AND gate operation. Guys, it is nothing new. It is a 10th class. We have a truth tables are there. In the AND truth table is also there. If you are don't know, please check it once. Yes. Very simple, guys. Here it is. It's a comparison type only we are using here. So think like that, but it's not a comparison. So in an AND gate logical operation, it is not a mathematical operation, logical operation. 0 0 means its output is also 0. So both inputs are ones, output is 1. Any input is 0, output is 0. Okay. So by that one, so you can able to check the network ID of a particular IP address with their subnet mask. So here it is a default subnet mask are there for any IP address from class A or class B, class C. There is a default subnet mask. Class A 255.0.0.0, Class B 255.255.0.0, Class C 255.255.255.0. Blindly remember, guys, network portion is 255, host portion is 0 blindly. But it may changes in a different places, different organizations. Okay, so that is by doing subnetting. But here it is. What is the default subnet mask for class A is 255.0.0.0. Default subnet mask for class B 255.255.0.0. Default subnet mask for a class C 255.255.255.0. See, there is an PC one IP address is 192.168.10.20, and it's a class C IP address. Then what is the subnet mask? 255.255.255.0. Okay. Now network ID, how we are getting? First convert these numbers into binary and do end operation. If you see 1 1 is 1, 1 1 1, 0 1 0, 0 1 0, 0 1 0, 0 1 0, 0 1 0, 0 1 0. 1 1 1 again 0 1 0 0 1 0 like that. So you go to last. There it is a 0 0 0 is also there, and 1 0 0 1 0 0 0 0 0 000 kind of stuff. So whatsoever it is, first bit is like the equivalent bit 1 1 1 1 1 1, but this is 0 1 0. Here it is 1 1 1, but it is 0 1 0. This is 1 0 0 0 0 0 1 0 0. So like this. So we got this one by calculating. So this is the network ID for this IP address. Again, both the devices network ID same, they will communicate each other. Since it's a same LAN network only. Guys, understand what is subnet mask? These ranges also you have to remember. Got it or not?
Yes, sir.
2 points I will tell, then we'll go to this private IP part because NAT is also there. That's I will tell after break. Okay. Here's a concept is how to write a subnet mask. When you see an IP address, we can understand which class it is. Guys, subnet mask is for class A, class B, class C only, not for D or E, does not have any classes. Okay. So remember, first three only. And first three only we are using, first three are subnet mask only. Okay. So this is my class C IP address. I want to write a subnet mask, then I will write it. Normally, someone asked what is your IP address, you told an IP address. But generally, you have to tell a subnet mask. But if you don't tell a subnet mask, not a problem. It is a default subnet mask. If you don't tell a subnet mask, means you are using default subnet mask. The same subnet mask, either you are not telling, then we can understand, or you are telling a subnet mask directly. My IP address is 192.168.10.110 and my subnet mask is 255.255.255.0. Next one is I can write the same subnet mask because it is look like a very big. Spell is also very big, right? You have to say it is a bigger. The same subnet mask you can write in the slash notation. Slash notation. Slash notation is represent the subnet mask. Slash notation is to represent the subnet mask. This method we call it as a CIDR method, classless inter-domain routing. Classless inter-domain routing. Also, some places we call it as a prefix. The prefix means you are telling about a subnet mask or representing network ID. So network, you use it for a like a network and host you are dividing. Guys, in subnet mask, all are ones only. It is always like a 1 1 kind of stuff. See, it is 1 1 1 1 1 1 1 and then zeros. All 1 1 1 1 1 1 1. See, always follow ones like this only. Not 1 0 1 0 kind of stuff won't be there in the subnet mask. So, what is this slash notation? Number of ones in the subnet mask. You see, it is 255 means one octet. It's a 255 means 8 ones. 8 ones. 255 means 8 ones. 8 ones. And here it is. How many 255s are there? 3 255 means 3 into 8, it is 24. So that's why it is written as a slash 24. Okay. So for example, you take 255.0.0.0 network. Okay. 255.0.0.0. This is the subnet mask. You want to write, then /8. 255.255.0.0. This is your subnet mask. How to write /16. I have another subnet mask 255.255.255.128. This is manipulated subnet mask. The /25. I will show you there. This it is. This is the subnet mask. It's a working subnet mask only, but it is. I changed the subnet mask from the default to some customize. I will tell why I change, but how it is written. It is convert all the 255, 255, 240 into numbers. It's a 20/20 it is. And see it is a very big. So these are all 24 plus 3, 27. Okay. So 255 means 8 ones. Other than 255, like a 240 or 224 or 192 or 128 or a 252 or 254. See those ones are there. You have to put it inside. Then we can find the slash notation. Okay. This is how to represent a subnet mask in the slash notation. As I said, guys, here I change the subnet mask from the default to some other type of subnet mask. If you are using default subnet mask, that is a classful network. In a classful type of network, so subnet mask, if you don't tell also, you will understand. But you change the subnet mask, compulsory you have to tell a subnet mask. So that if you change the subnet mask, it is a classless. So it is class C, but this is classless. Guys, see it is, here it is. This is an IP address and it is their default subnet mask. This is the network ID we are getting by calculating using AND operation. You have to convert everything into binary, then calculate network ID. Here, same network, same IP address kind of stuff, but subnet mask is different. Then I'm trying to calculate. My network ID is different. So it is look like a same, but network ID is different. So it is a default subnet mask. So this type of network is classful. This is not a default subnet mask. I change the subnet mask. It is a classless. Okay. Why we are changing this kind of stuff, guys? There is a reason. The concept name called as subnetting. Subnetting means divide a IP network into multiple subnets. For example, I have a class A network is there. The class C is there. In single class C, I am getting 254 IP addresses. I have a 10 servers are there or a 20 servers are there. I need an IP address for the 20 servers. So then I go to this regional center, I can kind of stuff, ask I need a 20 IP addresses. They will give you a network. In one single class C network, how many IP address we are getting? 254. How many computers I have? How many servers I have? 20 only. Means almost 234 IP addresses will wasted. Okay, will wasted. For example, I have a 500 computers, 500 IP addresses required. Then I request for an IP address. So it is more than class C, then they will give class B. So remove the 500 from this range, 65,000 IP addresses will be wasted. So what they will do, they use a different type of techniques to manage it. So one of the technique is subnetting concept. This subnetting concept will divide one network into multiple subnets. Okay. So purpose to save and better utilization of public IP addresses. So it is basically based on number of hosts per subnet or number of subnets requirement. Like I have a one network, I want to divide into 4 or maybe 8 or maybe 16. I will divide it as per my uh, option. Okay. Or I have a 50 computers in a one single room, 20 computers in another network. So another requirement from some different client is only 10 IP addresses. So based on that, I will divide a network into small subnets. Okay. To achieve subnetting, you have to change the subnet mask. You have to change the subnet mask. By changing of subnet mask, your network will be changes. See, you can understand this is the host portion, this is the network. Okay. So it means these two are stable, this is changes, right? Two portions means 2 to the power of 16, 65,534 IP addresses in this network. But here it is different. It's of only one host. Even it is a class B. When it is a class B, because of this IP address, you are getting only 254 IP addresses. Similarly, I have written something here. It is 128. 128. So this is 2 to the power of 8. 256 means 254 devices we are getting. But this is 2 to the power of 7 means 128 means minus 2. 126 devices only. In this type of network, only 126 devices only. So this is 224, right? If you use this subnet mask, number of devices per network is, one second, it is 128, 64, 32, 16 means 31 devices or 30 devices per subnet you are getting. Only 30 computers you can use it in the one single subnet. In this one, it is more, you can see, okay, the 256, no, well, no, it is, how many zeros we have to count it? 8 zeros, 9, 10, 11, 12. Okay, so like you have to get 2 to the power of 12 kind of stuff. 2 to the power of 13 minus 2, those many you have to do it. Okay, 2 to the power of 13 minus 2. 2 to the power of 10 is 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. 2000 to the power of 12 is 4096. 4096. 2 to the power of 13 is a 8192. So almost 8190 devices can able to connect in this subnet. Okay, this is basically class B type of thing. See, it's a class B kind of stuff. In the instead of 65,530 for IP addresses, here we are getting only 8,190 IP addresses. Yeah, you don't understand, no problem. Okay, but understand what is a subnetting? Very simple definition. Divide a IP network into multiple subnets. How to achieve this subnetting? By changing a simple subnet mask. You can do subnetting based on as per the subnet's requirement or a number of hosts per subnet. If you are using a default subnet mask, it is a classful network. If you are using different subnet mask, means changed subnet mask, means it is a classless. Like you use this subnet mask, it is a network is classless. Okay, this is about your to subnet mask, guys. This part is there. So then also we'll see other few more things after small break.